So, welcome again. This is part one of module two. In this module, we will talk about some challenges in AI development. So, we agreed that we are talking about AI and machine learning as system of software. So, it means that we have several challenges actually for these systems when we develop, as like software systems, but these are unique challenges. So all the challenges applied for the software development, for the normal software, classical software development, all these are applied again. However, we have unique challenges here for the AI software also. So here we discuss specifically the challenges related to the AI system. So one of the things is that AI in general nowadays for the development, there are two perspectives. The old perspective is the model-centric AI, which is we focus on the model. So it means that whatever the data is, we do some simple pre-processing for the data, but we focus more on the model, which means that we focus on the parameter tuning, choosing the best model, trying different algorithms to choose the model, and so on. So this is the model-centric AI. However, we have data-centric AI, which is the new direction of AI development, which is like we use some standard models or good enough model, but we think that, or researchers think that the most important thing is the data. As much as you have high quality data, then you get um, better model or better output of the model actually. So there are several challenges in both directions, whether you are following the data-centric approach or you are following the model-centric approach. For the data-centric approach, for example, there are several challenges. For example, the data limitation. Sometimes you have low quality data or you have insufficient data. Of course, there's a question also, how much data is sufficient? That's also a question, but also you have data quality challenges. Like you need to know that the data is reliable and accurate. And also during the data collection, you have challenges. You want to collect diverse data that represent several minorities, for example. Data labeling, who says that the labeling of the data is correct? So you make sure that the data labeling is accurate because the model depends on these labelings for the decision and for the training. Data privacy also is very important nowadays. When you have data, you have a lot of personal information about the data. You want to make sure that the data privacy is assured, and also the data bias. Also, that's a challenge. Sometimes the data is not representing is bias. So you have to mitigate this bias actually by the data. You have to make sure that the data is biased and fair in order for the machine learning to give fair decision. Also for the model centric approach, you have several challenges. For example, sometimes the model is very complex, and sometimes the model is good but cannot handle large scale data set and decision. Interpretability also is a problem nowadays because sometimes it is a must to interpret the decision. So the model is giving a decision, the decision is good. However, you need to interpret why the model gave this decision, why not other decision. Robustness also reliable and consistent. So the decision now is good, but after 1 week, it gives some other decision when the decision is good for some specific data, but is not good for some other specific data. So it should be a good decision always. Ethical considerations also, bias again, here for the model, you have to make sure that the model is biased and fair. So one of the issue for the data is the data quality. Data quality nowadays is a very problematic thing, because you want to make sure that the data has a good quality, and in order to have a good decision by the model, you have to feed the model with good quality data. So it is the degree in which the data meets the requirement of the intended use. So in ideal case, the AI algorithms assume that everything is ideal. Everything ideal means what? Means that the existing data classes are equally represented. There is no underrepresentation or inequality. For example, there is sufficient large number of training, so the data is sufficient. Uh, the feature values are consistent, and instances are correctly labeled. The labels are good also and consistent. Features are informative, of course. Training and testing data, the same distribution they have, all feature values are available. However, in reality, this is not possible, and this is not intended as it should be. So the data quality issues, we have several issues for data quality. For example, these are just some issues, but we have several issues of data quality. For example, the completeness. So sometimes you get the data, but there are several missing data points. So it means that the data is incomplete. Consistency. Sometimes there's conflict and duplicated data. The conflicting means that the data for a user is something in one column is another distribution in another column. So it means that the data for the same user is inconsistent, for example. Accuracy, sometimes that you get the data, but the data is incorrect actually. You get the data from a faulty sensor, for example. So the data is not correct actually. Timeliness, delay. Sometimes you get the data, but there is a delay in the data, which means that the data is not related to the instant that you want, and that takes us also to the relevancy. Sometimes you get the data after 2 minutes, so it's not relevant when you need the data to be real time. So that takes us also the data quality issues comes from data error. So you can change, you can use these interchangeably actually. Example of data errors, you have missing values, a null value or things like that. You have missing values, missing cells in the data. Outliers. Some points of the data are different, greatly different out of the distribution. So these are outliers. Duplicated data. Sometimes you get the data for 100 points. After 100 points, you see that these 100 points are repeated for the next 200 points, for example. So this is duplicated data and doesn't mean any, it doesn't contribute to the training that much. Biases, sometimes you get more data for some minority, some more data for some majority, and less data for some minority. So it means that the model is going toward the more data because that is more represented. Redundant values, sometimes there are several cells that are not related to this data. Data skew when training and serving data are not representative for each other. Data drift, also the change of the data. The data is changing after some time. For example, the weather data of this year is not as we collected for the last year or for the before 10 years due to the climate change. So you cannot use the data of the weather for before 10 years. It should be up to date. So some examples of imbalance data. You see that, for example, there are some majority MAG, MAJ, and MI some minority data. So you can see this data is the decision surface in the left-hand side is quite clear. However, the other side, the data is not balanced enough. Also, you can see that the data point, the decision service is not clear here. So you can see also more data points for the majority, less data point for the minority. It means that the data is not balanced. When you train this model, you can see that the model is giving decisions toward the majority rather than the minority. Underrepresented data is also something, some issue here. So you can see that, for example, there is a majority of data, but also you can see that there are underrepresented data within the class. So that that class is imbalance, of course, but you have to make sure that you are taking these underrepresented data into consideration when you train. Some techniques like clustering are useful here, for example. Thank you.